Hi everyone. Today we're going to study division of radicals. First, let us define the quotient property of radicals. Suppose I have two radicals here. The first one is the nth root of A. The second is the nth root of B. Take note that the index are same. And these two radicals are both real numbers. Another condition is that the B, this B is the radicand of the second radical here, should not be equal to 0. And for any integer n, and that is the index, should be greater or equal to 2. Then, if we're going to divide the nth root of A by the nth root of B, the answer will be a big radical here with index n. Inside the radical is a fraction with numerator A and denominator B. So this is the quotient property of radicals. Let's have some examples. Let us consider example 1. Square root of 15 over square root of 5. Obviously, our index are the same, so we can solve this problem using our quotient property. So this is equal to the big square root, and the fraction inside is 15 over 5. So we can now divide the 15 by 5. So the answer is the square root of 3. Let's have example 2. The square root of 48a raised to 7 divided by the square root of 3a. This is equal to the big square root, and the fraction inside is 48a raised to 7 over 3a. So we apply now the quotient property here. Next, inside the radical, we're going to group the coefficients and we're going to group the variable a respectively. We're going to simplify the 48 divided by 3. We will get 16. And the a raised to 7 divided by a, we can cancel that a in the denominator. We cancel the exponent 7. Then this will now be exponent 6. So in here, the answer will be the square root of 16a raised to 6. The next is the 16. We're going to show that this is equal to 4 squared. And then for the a raised to 6, we're going to represent this by a value with power 2. And inside the grouping symbol is a cubed. Next, we're going to distribute the square root into each of the factors here. So you see we have now the square root of 4 squared times the square root of the square of this a cubed. And then we can now cancel the square root and the square in this first factor. So only the number 4 will come in the final answer. Also with the second factor, we cancel the square root, also the power 2, only the a cubed will come down here. So the final answer is 4a cubed. Let's have example 3. We have here the cube root of 24x raised to 8, y raised to 4, all over the cube root of 81, x squared y. So we will apply our quotient property. So we're going to combine these two radicals into one big cube root. The numerator will be the 24x raised to 8 y to the 4th. divided by 81x squared y. And then we're going to group the numbers together. We're going to group the x together, also the y's together. For the numbers, we're going to simplify this by factoring out a common number to the numerator 24 and to the denominator 81. So the 24 is now factored out into 8 times 3. The 81 is factored out into 27 times 3. For the x, with power 8 in the numerator and power 2 in the denominator, we can show that this is x raised to the difference of 8 minus 2. And then times the variable y raised to 4 minus 1. So in here, the exponent is 4. In the denominator for the y, the exponent is 1. Next, we can now simplify our coefficients. We can now cancel the 3. So only the 8 over 27 will come down. For the x, we have the 8 minus 2. We have the power 6. So x raised to 6. For the y, we have 4 minus 1 power. So we have now the y cube. Of course, they are all inside this cube root. The next is we're going to group together this 8x to the 6th and to the y cube. Put them all in the numerator. The next step is we're now going to simplify by quotient property. It means we're going to distribute this radical sign, the cube root, into the numerator and in the denominator. And then we're going to use the product property to simplify by distributing the cube root to each of the factors. So we have the cube root of 8 times the cube root of x raised to 6 times the cube root of y cubed. Then in the denominator, still our cube root of 27 is there. We're going to show this 8 to be 2 cubed. For the x raised to 6, we're going to show that to be a power of 3, and then the x squared will be inside this grouping symbol. So from here, we can now simplify. We can now cancel the radical and the powers respectively. So for the first term, we can cancel the radical with the power 3. So only the base 2 will come here. In the second term, we cancel the radical also with that power 3. Only the x squared will come here. On the third factor, we can cancel the radical, also that power 3. Only the y will come here. In the denominator, we can cancel the radical and also the power 3. Only the base 3 will come here. So for our final answer, this is 2x squared y all over 3. Thank you for watching. See you again next time.